going to do a ALU block diagram. So before we start, we need to open a new file so we can save it in any way that we want to. Then after that, we just click next until the finish button. So we need to open a new file, a new block diagram file. Then we open it, and this is the full adder that we need to make. So we can just simply add the adder that we need. Then we need to add 2 XOR gate and 3 AND gate and also 1 OR gate, like what we showed on the video. After that, we need to put the output and connected them, and also we need to label each of the input and output so that when we simulate the waveform, it will be easy. Then we can save the file. To know whether our block diagram is correct or not, we can compile it by clicking the simulation. Then if there is no error, then we can make a waveform. To make a waveform, you also need to open a new file and then find for the universal program VWF. When we go into this file, we just need to right click on the left bar, then we click it and then list all, then we select all and OK, then OK again. Then we can change the timer or the high and low by ourselves, and we need to choose the override clock for 1 bit. We can set the period by ourselves. For this, I will set for 80, another one 160. Then before we simulate the program, the waveform, we also need to delete a code that I'll show on the screen. For every simulation, we need to delete this code, then we can start simulate it. And we also need to save for this simulation file. And then that's it, we got the output, and this is the output. After that, we need to save this schematic file into a block diagram that we created ourselves. So we click the create and update and create for current file. Then we save it, and then we got it, the block symbol. After that, we need to do a adder and subtractor by using the full adder block diagram we created just now. So you just click the project and we can get the block diagram that we created just now, and it will make our schematic file more simpler. So this is the final schematic circuit for adder and subtractor. So if our circuit have more than 1 bit, then we need to use a bus wire. So we will connect the bus wire for our input and output with 4 bit. After that, we need to label each of the input and output with the symbol we need that we want with bracket 3.0 bracket. After that, we need to define by clicking the properties of each line, like A bracket 3 and so on. Same goes to our input B and also output S, which also contain 3 bits. Then after that, we can compile it to check whether the circuit is correct or not. Then after that, we can simulate waveform. To change the value of the 4 bit, we can first highlight it and click for this one. And we can choose the bit that we want to for the input. For any input, we can set it ourselves for A and B. And this is the result after we simulate it. After that, we will add some XOR and also NOT gate for represent for our XOR and XNOR. And remember, we also need to add the bus wire for the output of XOR and also XNOR. And this is the circuit looks like. since it's too complicated, so I will just give it the procedure. You guys can refer to this to make the circuit. And this is the waveform after we simulate it. For I2, it represents the XOR gate, and for I3, it represents the XNOR gate. Next, we also need to save this schematic file into a block diagram, same like how we saved before, and we can find it. After that, we will do a 4:1 multiplexer, and this the circuit looks like. And this how we do it by using the Quartus. You guys can refer it, and remember the bus wire. So remember, when we save the file, we cannot save it as 4 × 1 mults. The first letter cannot be an integer, otherwise it will be error. So we only can save it as mux 4 × 1. After that, we also need to save this into a block diagram so we can use it after that. Next, we will do a 4-bit 4 × 1 multiplexer by using the block diagram we created just now. And this is the finder. Remember to place the bus wire. For part 3, we will do a 4-bit DFF. So first, we can search for DFF block diagram. Then we place it. And this is how it looks like for the finder. Remember the bus wire that we need to place it for more than 1 bit input and output. When we save this file, remember don't save it as DFF, otherwise it will be error. So we can save it as DFS1 or 2. Same goes, we need to save it as a block diagram so we can use it for future uses. Now we do for part 2 ALU. So first we need to import the block diagram that we created before, and then we need to connect them in this form. And same goes, we also need to save it as a block diagram. We can save it as ALU. Finally, we combine all the part 1, part 2 and part 3 together. Just use the block diagram that we created before, and we need to connect them in this form. After that, we need to connect them, and this is how the circuit looks like. After that, we will simulate it. Same goes for the input, we can set it ourselves, then we will check it for the answer. For the SU input and BSU input is a selector for A and B. For the ALU seal, when it's 0, 0, it will do adder, 0, 1 will do subtractor, 1, 0 will do XOR, and 1, 1 will do XNOR. And the output will be ALU out.